Hello everyone, hope all of you guys are doing well. So this is our experiment 624, identifying cations in solutions. I hope you guys have read the procedure and also the information that you need to know for this particular experiment. It also talks about how to identify the cations in a solution by doing different experiments, and also how to write the molecular equation, complete ionic equation, and how to find the spectator ions, and then finally how to write the net ionic equation. Okay, everything is written down very well here for you to understand. You can read it leisurely and understand. Also, how we're going to be performing the experiment, and what are the ion that we normally test in a compound, and what reagent we use, and then what is the product when those two ions, the reagent and the ion mix, what kind of a product is being formed. So everything here with the complex, the type of the complex or the compound, and what is the color of it, whether it is a solid or it's going to stay in the aqueous medium, everything is given here. Okay, also how you need to perform the experiment. So you can also watch the virtual experimental video to see how the experiment has been performed, and also what is the identity of the compound, whether it is a solid or a liquid, when you are performing the reaction. Okay, so I'm not going to go into detail as to how this is being done, since you can read it and understand, but I will help you with some post-lab questions. In the sense, you don't need to worry about this part. Let's go ahead and see how we can write down the equations. And in your data sheet you will see, when you are studying reactions of iron, basically we are using iron nitrate, and with potassium thiocyanate, what is the observation, and then with hydrochloric acid, what's the observation, sodium sulfate, what is the observation. So all of these observations are given in your data sheet. Okay, so you can refer to that. And same thing with the barium. So whether the barium nitrate going to react with potassium thiocyanate. With iron nitrate you will see a red complex, but with barium, potassium thiocyanate will not give you any red color. So you know it on the potassium thiocyanate only react with iron nitrate, not with barium. So likewise, by looking at the observations, you can see, which ions give a compound or a complex or a solid or a color change with a particular reagent. And this one with lead, how the lead nitrate behaves with these reagents. And then you will be given an unknown, and the unknown, when unknown react with potassium thiocyanate, if it become a red color complex, then you know it has iron in it. And if it has chloride, it gives you a white precipitate, then you know there could be lead present in your solution. Okay, and then if it is a sulfate and the unknown gives you a white precipitate with sulfate, then you know you can have some barium in it, because the barium sulfate is a white compound, right? So likewise, by looking at these observations, you can find out what are the kinds of ions present in your unknown solution. Okay, I will help you with how to write the molecular, complete ionic and net ionic equation for the reactions that you observed. So the first one is the ion. Write the molecular, complete ionic and net ionic equation for each reaction you observed with iron. So iron nitrate with potassium thiocyanate is what is what you did at the beginning, right? So iron FeNO3, oops, FeNO3. When you add iron nitrate with potassium cyanate, KSCN, potassium thiocyanate, it's going to give you a complex FeSCN nitrate plus potassium nitrate. And this one, all of these is in aqueous medium, so you put little AQ next to it. That tells you that it is soluble in water, AQ, aqueous or aqua. So, so this is called the molecular equation. And then the net ionic equation is all of these complexes that are in aqueous, that you can separate them into ions. Okay, so if you separate iron nitrate, iron is 3 plus, nitrate is minus 1, so the iron nitrate formula has to be like this. So when you separate them into iron nitrate aqueous, so it's gonna separate, this is called total ionic equation. Iron is 3 plus in charge, so you have to put little AQ for all of these to represent that they are soluble. And then there are 3 nitrates, so 3 nitrates, and when you write, you also need to write the charge of the complex. And potassium thiocyanate, it is going to separate into 2 ions, K plus ion aqueous plus SCN thiocyanate aqueous. So that's going to be all your reactants, and your products. Iron thiocyanate nitrate is going to separate into 2 ions. One is FeSCN, and that's going to stay as a 2 plus complex, charged complex, plus nitrate. There are 2 nitrates aqueous, and then the potassium nitrate K plus plus NO3 minus. Okay. Okay. Now in this one, I'm trying to see if this is balanced. 2 nitrate, yes, 2 nitrate and 1 nitrate. Okay, so we have 3 nitrates on the right side. It is balanced. Okay, so now we're gonna look. So this is the second equation that I have written. It is called total ionic equation. And then the last one is the net ionic equation. To write down the net ionic equation, we identify the ions that you can find in both sides of the equation, in your reactants and the products. What are the common ions? So we have iron 3 plus on the left side. We have 3 nitrate ions in the left side, which is our reactants, and on the right side we have 2 nitrate plus 1 nitrate, 3 together. So these nitrate 3 and 3, they are called spectate ions. So we can cancel them. And then what else is there? So you have a K plus ion, they are called spectate ions. So when you are writing the net ionic equation, you get rid of the spectate ions, and then you write what is left. That is going to be your net ionic equation. Fe3 plus aqueous plus SCN minus aqueous, which is this one, giving you this complex FeSCN2 plus aqueous. That is the red complex. So that is going to be the net ionic equation. for each reaction you observed. We observed this reaction, so you can write these three equations. Iron nitrate with HCl, no reaction. Iron nitrate with sodium sulfate, also no reaction. Iron nitrate with sodium sulfate with sodium acetate, also no reaction. So this is the only reaction that took place. So you only need to write equation for this one. And then the next ones are doing some reactions of barium. So barium reacted with barium sulfate. So we can do that and write down complete ionic and net ionic equations. Okay, so barium nitrate with sodium sulfate. Barium nitrate. This is the molecular formula for barium nitrate. Aqueous plus sodium sulfate Na2SO4. Aqueous. It's gonna give us sodium nitrate, 2 sodium nitrate aqueous plus barium sulfate. Now barium sulfate was a solid, it precipitated out. Okay, and let's see if the reaction is balanced. It is balanced. So this is the molecular equation. And then the complete ionic equation, everything that remains in aqueous, you're going to separate them into ions. So the barium nitrate can be separated to barium 2 plus and 2 nitrate. All of these are needed to be aqueous. Plus there are 2 sodium ions plus sulfate. Charge of the sulfate ion 2 minus, you need to write that down, and 2 sodium ions in sodium nitrate. Sodium is plus 1 charge, aqueous, plus 2 nitrate, that is this one here. And then the barium sulfate, you do not break them into ions because it's a solid, so you're going to leave it as barium sulfate solid. Okay, and then you're going to identify what are the spectate ions. So the common ions that we find in both sides, 2 nitrate, 2 nitrate, 2 sodium, 2 sodium. So once you leave the spectate ions outside, what you're left with is barium 2 plus aqueous plus sulfate ions aqueous, giving you barium sulfate solid, and that's going to be your net ionic equation. Okay, so with barium nitrate with potassium thiocyanate, no reaction. With HCl, no reaction. And barium nitrate sodium sulfate with sodium acetate, also no reaction. So this is all you need to do for this part. And then with lead, write the molecular complete ionic equations for these ones. And again, the lead nitrate with potassium thiocyanate, no reaction. But lead nitrate with hydrochloric acid, it gave us a white precipitate. So we can write that down. Lead nitrate, PbNO3 aqueous plus hydrochloric acid aqueous, giving us lead chloride, PbCl2, which is going to be a solid, plus HNO3 nitric acid, which is also going to be aqueous. Okay, and then we need to balance this. You can put 2 here, and then if you put 2 here, that would be balanced. So that is going to be our molecular equation. So the net ionic equation would be, we are separating into ions the one that is soluble in water. So the lead ions, we need to represent the charge of the ion. Lead is 2 plus aqueous, plus there are 2 nitrate ions, plus 2H plus aqueous, plus 2Cl minus, giving you PbCl2. Lead chloride, since it's a solid, you do not break them into ions. You're going to leave it as it is. And then the nitric acid is a strong acid completely soluble in water or dissociate in water. You write it down, separating them into ions. Okay, and then you're going to identify your spectate ions. So what are the spectate ions here? What are the common ions? 2 nitrate, 2 nitrate, 2H plus, 2H plus. So what is left is Pb2 plus aqueous plus 2Cl minus aqueous, giving you PbCl2 solid. That's going to be your net ionic equation. Okay. And lead nitrate or with sodium sulfate also, it gives you a precipitate, lead sulfate. Okay. So this is with lead nitrate with hydrogen chloride. So we can also do the other one. I'm going to erase this. So we can write down the reaction with sodium sulfate. Okay. So lead nitrate with sodium sulfate, Na2SO4, which is also going to be aqueous. All of these are aqueous. Going to give us lead sulfate, PbSO4 solid plus sodium nitrate. Okay. Now that is the molecular equation, and then the total ionic equation would be, you're going to separate these into ions except lead sulfate. So the lead nitrate Pb2 plus aqueous plus 2 nitrate ions plus 2 sodium ions when you separate them into ions. And then you have sulfate SO4 2 minus aqueous, giving you the product PbSO4. Since it's a solid, you do not separate them into ions. And then sodium nitrate, since it is aqueous, you separate them into ions, plus 2 nitrate. Now you're going to identify your spectate ions. 2 nitrate, 2 nitrate, 2 sodium, 2 sodium. So your net ionic equation would be lead2 plus aqueous plus sulfate ions aqueous, giving you PbSO4 solid. Okay, that's going to be lead nitrate with sodium sulfate. And then we also saw that the lead nitrate sodium sulfate complex, or the compound that you made with sodium acetate, it's going to give you another complex. Okay. Do we need to do that? Okay. So it is, looks like it's probably, you can only write the molecular complete ionic and net ionic equation for these two. That should be enough for you guys. Okay. Okay. And then analyzing the unknown solution. Unknown identification code, this unknown number, what you did for the unknown number. So these are the observations which you have as data, and your identification code of the unknown is unknown number 7. So unknown, when you add potassium thiocyanate, colorless solution turned dark red. What does that mean? Which one gave you a dark red color? That was iron, right? So meaning your unknown compound has iron in it. Unknown with hydrochloric acid forms a white precipitate and solution became pale yellow. And that could be, remember, a lead chloride give you a white precipitate. So that is an indication that it has lead in it. An unknown sodium sulfate, white precipitate formed in colorless solution, which is again lead sulfate, barium sulfate, right? So the barium sulfate give you white precipitate. Okay. Yes, so you have iron, barium and lead. So the presence of barium confirmed when sodium sulfate was added to the mixture, and we saw a white precipitate formed. It says there is a white precipitate, and then the precipitate did not dissolve completely when sodium acetate was added. Okay, and the presence of lead was confirmed by forming a white precipitate when 1 mole HCl was added to the solution. So we can conclude our solution has iron, lead and barium in it. Okay, so you can answer that, and that's all you guys need to do. Yes, so just do that part. That should be good enough. Don't worry about this part. Yes, so you can do these ionic equations, and this will also help you in general chemistry 1, because we're going to talk about this again in general chemistry 1, and then unknown identification code, and then the cations present. All right, then I'll talk to you soon. Bye bye. Have a lovely day.